हम इस वीडियो में आज बात करेंगे कुछ प्रीवियस ईयर पेपर्स की, और जिसमें लास्ट वीडियोस में मैंने डिस्कस किया था बूलियन अलजेब्रा एंड बूलियन फंक्शंस बेस्ड क्वेश्चंस और सिंप्लीफिकेशन ऑफ सर्किट्स एंड क्वेश्चंस फ्रॉम प्रीवियस ईयर पेपर्स जो कि पूछे गए हैं आपके लास्ट ईयर पेपर्स में, जिनमें मैंने 4 साल के पेपर्स को देखा है 2019, 20, 21, 22। तो इन सारे पेपर्स में से जो भी क्वेश्चन आए हुए हैं ऑन द बेसिस ऑफ दिस बूलियन अलजेब्रा एंड सिंप्लीफिकेशन सर्किट्स, तो मैं उन क्वेश्चंस को आज सॉल्व करूंगा एंड इट विल श्योरली हेल्प यू इन योर एग्जाम, बिकॉज इन योर एग्जाम्स दे आस्क यू क्वेश्चंस फ्रॉम this portion, 2 to 3 questions from this portion. So let's solve the questions, and before we move to the solution of these questions, we will look for these questions, right? So let's start from 2000. Let me show you questions first and then I will solve. So the first question that is asked is this: x1 and x2 complement, or x1 complement and x2 complement. So if you know the rules, then you can easily draw a logic circuit, right? Okay, so two types of questions are asked. First, to draw a logic circuit based on some Boolean expressions that is given in these questions, and sometimes they draw a logic circuit themselves and ask you to find the Boolean expressions, okay? And sometimes they ask to simplify the given Boolean function. So when they ask you to simplify the Boolean functions, then you must remember the Boolean algebra laws and the understandings of basic kits like AND or NOT, NOR, XNOR, NAND. And if you have any problem in these topics, then you can watch my previous videos and in this playlist of discrete mathematics, and you will find the questions. So there is a questions that are asked from your previous peer paper, that you have to find Boolean expression for the following logic circuit. So again here they have given you the logic circuit, and in that previous questions they ask you to draw a logic circuit. So okay, so this type of questions are asked from this portion. And then if we move further, then you will see that that was February 2021, right? So, and another question asked from your previous year paper of 2020, in which they ask you to draw the circuit represented by the following Boolean function f is equal to xy plus x complement y. So here you have to use the basic gates and an OR, and then a NOT gate, and to draw this circuit. So I will solve these questions for you from these previous year papers, right? Then one question that are asked in in 2019, right? So in which they ask you about the same type of questions, and it was the June 2020 question paper, and in 2019 they asked you to simplify this Boolean circuit, logic circuit. So you have to give the output of the given circuit, which is of the 4 marks. So now you know what type of questions are asked from your exams, and how to solve it, these type of questions I will just tell you. And then that was the paper that was in your this is the paper that was from your 2022 exam, right? So here you can see, if you look it closely, that this is the question that is asked in your exam, right? This one, right, on the right hand side, MCS212. That was the question, that was the paper of the previous year, right? The exam that were held in February 2022. So जो फरवरी 2022 में आया था, उसमें भी 3 नंबर का क्वेश्चन था, जिसमें पूछा गया था कि you have to find the Boolean expression for this, right? So let's start solving this question, and let's start from this side. So you have AB, which is input to the AND gate, and then NOT gate, right? Then we have C, which is again connected to the AND gate, right? C is connected to the NOT gate, and then we have this AND gate, and then we have to find the O, which is output. So this is asked in the 2020 paper. और उसके बाद जो क्वेश्चन पूछा है ये है फाइंड इफ द बूलियन एक्सप्रेशंस आर इक्विवेलेंट फॉर आवर टू बूलियन अलजेब्रा B01 this and this. So if you know the functions for A and B and C, and if you know the gates, because these are the gates basically, this is AND gate and this is for OR gate, this is conjunction or disjunction. So around 7 to 8 or 10 marks questions are asked from the Boolean algebra, from the preposition logic and logic gates, right? It's very simple and easy, right? So now start with this question, and let comes to this notepad, right? So so first of all, look for this that was asked in February, right, 2022. But in the paper they have written 2021, but it was held due to corona. It was held in 2022 February, right? In February. So the question was this AND gate, right? So here we have A and B, and then we have C, which is input to this NOT gate, right? And then these two, this again we have this inverter on NOT gate. Inverter on NOT is same, because inverter inverts the input. So if you supply 1, it will give you the output as 0, and if you supply 0 to it, then it will convert it to 1, right? So here we have these two outputs are connected to again with a AND gate, right? With a AND gate, and this AND gate is as this output is denoted as O. So simplify this, right? So this is your AND gate, right? This is your NOT gate. Again, this is your NOT gate. This is your AND gate. Right? Don't write in your paper. Just to explain you and just to make you understand the functioning of these gates. And so I am just writing the AND, NOT, and NOT, and right. So let's take this. So we have AB. So AND gate is nothing but the product of these two terms, A dot B, right? We denote it as A dot B. But when we talk about in conjunction or disjunction form, it is denoted as this conjunction, right? Like this, A and B. Right? So this is the same, because to interrelate the things, because in exams they want you to confuse, right? So sometimes they will use AB, sometimes they will use A dot B, sometimes they will use like this A conjunction B, right? Okay, now C, okay. So C, it will give you the C complement or C bar, right? Here we have A dot B, and then it will give you the A dot B, bar of A dot B. So now when we go to this, right, these two inputs or these two outputs will be fed to this AND gate, and for this they will be treated as input, and then it will be the O will be A dot B complement dot C complement, right? Okay. So now because these are from this input, so we can write it as A plus B, A complement plus B complement. This is why I have written this, because from the De Morgan's law you know that if we have X dot Y complement, it will be complemented to individual term, and then the dot will change to the plus, or you can say that AND will change to the OR gate, right? So this is because of De Morgan's law. So you have to write in your exam that because of the De Morgan's law theorem or De Morgan's theorem, we can write it like it. We can write it like that. So A complement plus B complement dot C complement, right? So this is it. So this is the solution for this circuit, right? This is given in your February 2002, asked in your February 2002 exam, right? So now come back to the another paper, which is of 2021, right? So in 2021 they have asked to simplify again this circuit, which is x1 and x2, and we have this x3. x1 and x2 are connected to this AND gate, right? This is OR gate, sorry, OR gate. Then this OR gate, the output of this OR gate is inverted. Then x3 is inverted, and these two outputs are fed to this AND gate, and then we have this again is inverted to the S using this NOT gate or inverter, right? And they ask that what is the value of F. So here again this is very easy. So this is your OR gate, right? And OR gate says that if two things are inputted, then it will be output as x plus x2. Okay, and then here we have x3, so it will be x3 bar or complement, whatever you say. This is both are the same. You say bar or complement. Okay, here we have x plus x2, which is again complement because of this NOT gate, right? This is NOT gate. This is NOT gate. Again, I remind you, if you don't know the basic concepts, you cannot solve these type of questions. So first of all, watch the previous videos to know about these basic gates, and then come back to solve these questions. You can, as well as you can pause these videos when you are watching, and then solve it yourself, and then compare your answers. So it will be the best way to prepare, right? Now this is AND gate. So what will be there, that x1 plus x2 complement, then dot x3 complement. Again this entire thing will be complemented, right? So the F, what will be the F? F will be x1 plus x2 complement dot x3 complement, and the complement of whole output because of this NOT gate, right? Now solve this. So to solve this, what we have to do, this is because again this is one thing, this is second thing, right? So you can apply the De Morgan's law because this is the complement of all over this. So what will be? So it will be x1 plus x2 complement and then complement, right? Because complement of individual term that we have solved, we have just I have just told you in the previous questions, and then dot will be converted to the plus, or you can say the AND gate will be converted to the OR gate, and then the complement of this term which is already existed, and then again complement. So the complement will be this term, right? So it will be x1, right, plus x2 plus x3. So this is your answer. Okay, right? So this is your answer, because the if I take negation of x and then the negation of this, or if I take the complement of x complement, so it will be x, because these two will be discarded. So that's why I have written this x plus x2. Okay, now another question. So if you have any doubt, so please let me know, right? Okay, now again the question that are asked in 2020, right? 2020. The question asked is to draw a logic circuit for this xy plus xy complement, right? So as they have given you, and then you have to use the basic gates and, or, and not, and then draw this circuit, right? Don't try to simplify this. I can simplify this because I can take x common, and then y plus y complement will be 1, so the output will be x. So using only one variable, how you can draw a logic circuit? So remember, in these type of questions, don't ask, don't go for the simplification, because they are not asking you to simplify this type of functions. They are just asking you draw the logic circuit for the following Boolean expression, right? So just don't try to simplify, just draw. So here which gate we have to use, because this is the AND, this is the dot operator or dot thing, and this is dot. So here, because we know that the dot denote the AND, or product denote the AND gate, denote the AND gate, and plus denote the OR gate. So we can write x y, right? X y, then these are for the AND gate. Okay, this is AND gate, so draw a AND gate. Okay, then these two are connected with the AND gate again. So because we have already taken xy here, so we don't need to use the again xy, right? Because we have already taken xy here. So we have what we have to do, we have to draw a AND gate, right? And then x, so we will directly feed this to this AND gate, and then y complement. So complement is nothing but your you have to use this inverter, right, or NOT gate, and this is complement the y. So x dot y complement will be fed into this AND gate, and then this is plus, so plus denote the OR gate. So the output of these two will be fed into the OR gate. So here we have this OR gate. So this is the logic circuit for this question. Again, I am telling you that please don't lose these marks, because these questions are very easy, but to solve these questions you must know the working of the basic gates, AND, OR, NOR, NOT, XOR, and XNOR, right? So let's go to the another question, which is asked in 2019 June, right? June 2019. This question was we have 3 inputs, and this is AND gate. Again we have 3 inputs. Again we have 3 inputs. Right? Again we have another gate which have 3 inputs, x, y, and z. All are negated, or all are inverted, right? And these outputs are fed to the OR gate, and they are asking you to the what is the value of f, or what will be the Boolean function. Okay, so here these 3 are connected to this. Okay, and then the output is xyz, 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 right? So just try to figure out this thing, right? So here we have xyz, so again this is AND gate, so it can be xyz, right? Then we have this, so here we have x complement yz. Then we have this is x complement y complement and z complement. Again this is the AND gate, that's why we are taking the product, right, or dot. Then this is OR gate, right? So f will be what? So f will be the addition of these three, right? So xyz plus x complement yz plus is x complement y complement and z complement. Okay, now this is your function and you can simplify it, right? So yz, take yz common, and then x plus x complement plus x complement y complement z complement. Then x plus x complement is 1 because of the identity law. So you have to specify here that using the identity law we can say that x complement is 1, right? So it will be yz plus x complement y complement and z, right? Z complement. So this is your answer. So again here you can see that we have to remember the laws, right? So again watch this discrete mathematics playlist in which I have already explained all the gates and all the laws, right? Now let me add another page. So the last question is from your 2019, December 2019. They have asked that draw for the following expression, which is x1 complement. They are using this dash here, right? Not this line. Okay. So x1 dash, so is denoting the complement again. This is for confusion, and then they have used the conjunction. Okay, x2 conjunction with x3 complement. Okay, and then this is this x2 or x4 complement. Again they want you they want to confuse you, right? They want to confuse you. That's why they are not using the plus and dot. They are using conjunction and disjunction. Okay. So remember, this denote OR gate and this denote AND gate. So it will be very easy to draw this circuit. So here we have x1 and x2, x3. So draw, write x1, x2, x3, right? Now in this case जो ब्रैकेट में है सबसे पहले उसको आप सॉल्व करेंगे. तो ब्रैकेट में क्या है, x2 and x3, right? x2 and x3. So for x2 and x3, okay, I just forgot one thing here, that this is not complete because x4 is all given here, and before that they have given x1 and x2 complement. x1 and x2 complement, and then they have x1 is like that, right? So you can easily let me check once if it is wrong, or here we have, this is the question for 2019, right? So we have this, let me check once again that I have just copied it rightly, or I am missing something. So this is this question, and then okay, this is the question, right? This is the question, right? Okay, I have just copied it from somewhere else, right? So this is the question, and x1 and x2 complement, or x1 complement and x2 complement, right? Okay, so we have this question. So this is not the question. So the question is x1 and x2 complement, then this is with this, and then x1 and x2, and then complement on both of this, right? You can also verify it from this x1 and x2 complement, or x1 complement and x2 complement. So x1 and x2 complement. Okay, now in this case what we have to do, we have to draw a logic circuit. So we have x1 and x2, right? And this is x1 and x2 complement. For x2 complement we have to use the inverter, then they are combined with the AND gate. Again remember this, I have just erased this, that this denotes the AND gate and this denotes the OR gate. Remember this, otherwise you will be confused. Then we have x1 complement and then x2 complement. So x1 complement, you can take the negation, right? Then we have x2 complement. So x2 is here, right? You can directly use this because x2 is complemented, so we don't need to use another AND gate for this, sorry. Then these are two are connected with this, and this represents the OR gate, so we have this OR gate. Okay, so this is the diagram for this this question, right? And the question that I just wrote previously, it was using the 4 variables like that. You can that was asked in 2018, right? So but here I just discussed about the 4 years paper, 2019, 20, 21 and 22. I hope this video will help you, and please remember all the laws and watch again and again these videos, and these videos will definitely help you to crack this paper, right? So okay, then keep watching and keep preparing. Thank you.